So here's a few thoughts on the tremendous diversity of file types that we have. We were also going to have tremendous diversity in contents of file, and we'll deal with that later because that's a whole different problem. But for now, what I'm trying to capture is the different file formats. Now, your computer already handles a wide variety of different kinds of file formats. So for example, when your computer loads this file, your computer understands that it is an HTML file. And so if I go and look at what that HTML actually looks like, it looks like this when I put it in a plain text editor. It is truly, at the end of the day, plain text. And your browser understands how to translate this into a file that you know what to do with. And especially if you have a Windows machine, all of that nitty-gritty detail is hidden deeply from you. Because if you were to just double-click on an HTML page, it's going to load it into the browser because it looks at the contents of the file and says, oh, this is HTML. It must need to be loaded into the web browser. And even Microsoft Word has some facility for reading HTML files. So your computer is understanding what the file type is and loading it into an application that makes sense for it. So, for example, there's lots and lots of binary stuff in a PDF file, but the very first characters in a PDF file literally actually say PDF because the computer needs to know what these files are. PNG files, similarly, the first line of the file, let's see if I can show you. I'm asking it to give me the first line of this PNG file. See, it says PNG. So your computer is already elegantly handling lots of different file types by looking at the contents of the file. And the contents of the file are all different depending on whether it's a PNG or a Microsoft Word file or a HTML file. All of these things are different contents, but your computer already knows elegantly how to handle it. Now, when you get into the world of astronomy, most of the time, we're dealing with variants of plain text files. Even a FITS file, the beginning of it, looks like plain text. So if you just more one of these FITS files, you'll see at first, well, my screen isn't the right width. Let's do this. That's not going to work. Let's make it a little bit narrower. Okay, you should start to kind of see it here. So there's a plain text stuff at the beginning of it, and that's part of the FITS header. And the rest of the file is binary, but the beginning of it is plain text because it is trying to explain to your computer and to you as a human reading it what the contents of the file are. And you can access those kinds of headers from DS9 or from Finder Chart by when it actually loads it in. What it does is it looks at the stuff in the header, and the stuff in the header is how it figures out where the coordinates are. And then the binary file is the image that it displays. But you can actually go and see that header by going there. So that's the header of the file. And at the end of the day, it really is just plain text on top of the binary. So that's already one step away from a file that your computer might encounter every day, although your computer, I don't know how you have it configured. It may recognize a FITS file as an image and drop it right into DS9. You might have to help coax it. Now, the other two kinds of file types that we're going to be using a lot here are table files and region files. 9 times out of 10, I would bet money that your computer does not know off the top of its head what to do with a .reg, which is a regions file, or a .tbl, which is an IPAC table file. And so there's two facets of things that are going on here. One is that your computer doesn't know how to handle those file types elegantly. And so sometimes you have to help coax it along. The other side of it is that each one of these file formats is custom to a particular application. So Finder Chart will understand table files and region files because we built it that way. DS9 will understand regions files, but not table files. Table files can be as long as you need them to be, but for most purposes, especially when you're searching for lists of targets, it's better to just have just the name and the right ascension and declination, because then neither you nor the computer gets confused. So a regions file looks like this. It's plain text. It's just my particular editor understands what a .reg file is, and so it's put it all in italics. But it is pretty easy to read once you understand what it's talking about. The very first line in the file is saying, oh, it's a DS9 regions file. Then it's got some parameters about how thick the lines are, what color it should be, the font that you use, and some other parameters. Then it's telling the computer, I want to use J2000 FK5 coordinates, and I want to put a point at this right ascension, this declination, and I want to make it a circle. And then I want to write right next to it at that position a number 1. And then repeat for the remainder of the 7 sources that we've been working with most recently. So that's all it is. It's just saying, put a point at this position, put a label at this position, and then go to the next position. A table file has 1 line per source, and it's got the name, right ascension, declination, but the header looks different. The header is saying something about how wide the columns are, and then it's got the contents of the columns there. Now, both of these interfaces, the regions file to DS9, or the table file to IPAC services, or for that matter, the regions file to certain IPAC services, can be a little sticky. If you are not 100% compliant with the format, sometimes the tools throw up its metaphorical hands and say, I don't know what to do with this file. So that is kind of what we were dealing with when I was trying to quickly do this kind of a demo when we were on the phone yesterday. So I had, let's see if I can get to it here. So I had in the box drive, I had for you a directory called papers, and then I had in it the DeFrancesco table. So the DeFrancesco table, as I had originally downloaded it, was in fact in IPAC table format, right? So it's got some headers, and it's got the column headers that are separated by these characters called pipes. On my keyboard, it's a key that you have to hit shift to hit, and it's above my return key. And then it's got the header information, and then each line of this file is an individual row of the catalog. It's an individual contents of the catalog. So it has all the information there, and you as a human are flexible enough to understand that underscore RAJ2000 means RA. But the computer is not that clever. So you have to help it along. Now, the rest of this file is 100% IPAC table file compliant, except that it doesn't understand that these are right ascension and declination. So what I did quickly, perhaps too quickly on the telecon, was I created a second file where the only difference was that I changed the header to be RA and dec lowercase, because I know that the computer will understand RA and dec lowercase. And so Finder Chart can read that in without a problem. And because Finder Chart has this flexibility where it can read in and export DS9 files, what I did was I put in, let's see if I can do my big search again. So I had 32 arc minutes, that's fine. So I get the image, okay, and then I can go and read in from the catalogs tab. I can search IPAC holdings. I can read in a catalog from disk, or I can search the VO. The VO is how I found this catalog in the first place. The load catalog here, we're going to go find the one with the fixed coordinates, okay, and we're going to upload it. Now, there's a known bug where, for reasons passing understanding, it loads in a gazillion copies. I don't understand why it loads in a gazillion copies. I have no idea, but it's on the list to be fixed. So we're going to delete all these extra copies. We're going to have just the one copy. All right, so it's got the thing in there, and it has an RA and dec. Let's see if it overlaid the sources. If we go click on that and go to the layers icon, we can tell it overlay that catalog. And sure enough, it does. It overlaid the catalog. It's got the shape that we expect. It's in the position that we expect. This is good. So it seems to have done it correctly. Now, the kludge that I was using on the phone yesterday was that now I've got an overlay. Of course, my overlay also includes my query object. So I'm going to tick off that so that I have just these coordinates. Okay. Now I'm going to go over here to the diskette icon and click to save just the regions file. And then it will download for me the regions file that has just those JCMT scuba sources. So that's what I did yesterday in order to make that regions file that then we can, let's see, where did it go? Let's see, where did it go? Where did it go? Maybe it's here. Yep. So there's the regions file. See, it's a regions file generated by Ursa, but you see it's got the same general syntax. It tells it, put a point at this position. Now these are boxes and they're green. So if I go over here and do region load and find the DiFrancesco thing and then explicitly tell it load it into all frames, it will load those positions into all of the frames that I have loaded. Now they're not super obvious here, so we can do region all. Let's make them, I don't know, cyan. Let's make them, instead of, let's see, a font. We need shape. Let's make them, circles are fine. Instrument, let's see, how do we make them bigger? It looks like we may have to change that manually, but we can also make them just plain thicker lines too. So there they are. There's those sources. Boy, that didn't help. Let's see if we can make it a different color yet again. Region, color, maybe red. Yeah. So there they are. And if I want to save them as red, I can click on save and save the file that way. So it's frustrating that not all computer applications read the same format files. But your computer already is doing that. Your computer is already reading files of many different formats because it's reading the information that's in the file itself, like this is a PNG file or that's a FITS file. It's already doing it elegantly. It's just that when you start to encounter regions and table files, you have to help your computer figure it out. So we're going to have lots and lots of different things to worry about. So I have here a list of just the 254 sources that are currently in our interesting list. And here's just a simple IPAC table, the name, right ascension, declination, and then a code that tells me why the source is in our interesting list. Here's the regions file version, and here's the whole catalog where it's got all the magnitudes and all the bands with all the limits. So we're going to spend a lot of time moving file formats back and forth so that different applications can read it. And unfortunately, there's not a lot I can help you with that, just by brute force. So, like I said, your computer is already dealing with lots of different file formats. This one is CSV or comma separated value. Excel will know how to read in that kind of a file. This is just something else I was working on. So if you double click on this on your computer, it'll probably drop it into Excel. But a comma separated value file is just a text file, and you can read and write it, using Excel if you want, or you can read and write it just typing it out longhand. So unfortunately, there's no way around the wide variety of different kinds of file formats. The things that we're going to encounter are regions files, which work in DS9 and Finder Chart, and table files, which work in Finder Chart, and all the rest of the Ursa tools for that matter. And that's just, unfortunately, the reality of it. What makes it even more complicated is that we're going to have different versions of the files. As we get into this, we already have different versions, right? We have the 7 sources we were working with for the section 3 from the resolution worksheet. We have 16 sources from DiFrancesco, and we have 254 currently on our short list of interesting objects. So even before we get into different file types, we already have 3 different files of things floating around. And as we get into our list of interesting objects, that number is going to change as we have a better understanding of, this U-band magnitude isn't right, or this Sloan source is not the same as this WISE source. And so this is going to change with time. So that is part of why when I'm going to make for you these different catalog versions, they're all going to have a date in it. They're going to have a timestamp in the top of the file so that you can try and keep up with the different versions of this information. Unfortunately, that is a confusing thing, but it's the reality of what we have to deal with. So hopefully this at least clarifies the difference between table files and region files and the larger issue of trying to help your computer understand what to do with those files.